Hi everyone, thank you for joining the team at Hands-On Labs today for our third webinar in our discipline-focused live demo series. Today's topic is dedicated to HOL's chemistry online curriculum and kits. Before I hand the mic over to our host, let me take a moment to review the webinar logistics and give a brief introduction to today's event. We encourage our attendees to participate in the conversation by asking questions and sharing resources. Please use the chat function to join in the conversation. If you do that, be sure to toggle the window that says to all panelists and attendees if you'd like the entire group to see your comment or question. If you have questions, add those in the Q&A box. You can find this section in your toolbar. We have several distance learning specialists on the panel today to help answer any questions you have in real time. Dr. Duane will address any remaining questions at the end of the demo so everyone has clarification on important topics. All attendees will be entered into a raffle to win a $100 Amazon gift card today. We'll share the lucky winner in our follow-up email at the end of the day, along with a recording of this webinar for you to reference moving forward. So, what can you expect to see today? During our chemistry live demo, our Chief Resident Scientist, Dr. Duane Cagle, will show you how to investigate the structure, properties, and transformations of matter with HOL's rigorous online curriculum and the powerful platform that hosts the content from both an instructor and a student perspective. By the end of this session, you'll be able to do the following: conceptualize HOL Cloud's 3E instructional model and how it supports active constructivist learning in an online setting. You'll be able to explore how students perform classic chemistry experiments, such as observing and describing chemical reactions and the like. Experience our advanced chemistry activities that require students to perform proper measurement techniques, record detailed data, and conduct qualitative and quantitative analyses. And finally, you'll be able to investigate the features in our powerful e-learning platform, the HOL Cloud. This makes teaching and learning chemistry online a seamless experience for both student and instructor. If you don't already know our host today, Dr. Duane Cagle is our Chief Resident Scientist and has been the brains behind Hands-On Labs curriculum development for the past 9 years. We also have several HOL distance learning specialists on the call today who will be manning the chat and providing helpful resources throughout the webinar. Without further ado, a warm welcome to Amanda, Taylor, Roger, Joe, Scott, and our main host, Dr. Duane Cagle.
Well, thank you, Audra, for that wonderful introduction, and myself and all the panelists are thrilled to be sharing our Friday afternoon with you. While you learn more about our learning platform and most specifically our chemistry materials and curriculum. And I want to just start out by saying, I know as an instructor, the thought of teaching your chemistry class online is probably intimidating and a little scary because we know how we do these things on campus, and it is really hard to envision this process online and for a student to use physical materials outside of the campus laboratory. And because I understand that, I know you're going to have lots of questions today. And that's when we have our panelists on hand, and they are going to type responses back to your shared questions as quickly as they absolutely can. At the same time, like Audra mentioned, I'm going to take time at the end of the presentation to answer any science-related questions that our panelists aren't equipped to answer. And then I typically take a little break about halfway through to catch my breath and open up the floor to some of those science-type questions that haven't been answered at that point in time. So without further ado, let's see if I can't get my technology to work properly on my end. And we will investigate an online chemistry course. So what I want to do to start out is to give a demonstration of how a student uses our physical materials, interacts with our curricular hosting platform, which we call HOL Cloud, to conduct chemistry labs online and submit their work to you, the instructor. So what we're seeing on our shared screen right now is the landing page for a student to access their lab manual curriculum. And we'll see that the curriculum is divided into two sections. The top section is labeled prerequisites, and that is indeed what those labs are. They're titled Getting Started in Lab Safety. Now, all of our online courses come with prerequisites, and at a minimum, there are two, and those are the ones you're seeing on the screen. Getting Started is designed to prepare a student and familiarize he or she with all of the controls from an IT standpoint on the HOL Cloud platform so that they can successfully navigate through their lab manual. Prerequisite number 2 is the most important of all. It's titled Lab Safety. And not unlike you have a lab safety hour or entire lab on students' first week on campus in your lab environment, we have a prerequisite lab safety lesson that students must complete before they begin engaging with any of our discipline-specific curriculum. As a company, we are very, very focused on student safety when using our physical materials. And I know as instructors that that is one of your biggest concerns when considering taking your chemistry lab online. So rest assured, we've taken every precaution possible to assure your students will be safe. And along that lines, we stand behind our materials and our curriculum, and we cover liability for your student. So there is no obligation on you, the instructor side, or your institution side should a student incur an accident. But I think you'll see that once we get into the curriculum and you see the materials, that a lot of your fears will be alleviated, and you'll see how we're so confident in what we do that we are the liability provider. So enough about prerequisites. I know you all want to see an example of what our curriculum is like, and it has photos of our materials. We put together this demo course just for these types of events. It has, 5 or so labs in it that kind of spread the breadth of our curriculum. So let's begin with the first title here. It's called Acid-Base Chemistry. And you'll see that as a student, when I click on this title, it opens up and I see 3 different kind of subtitles or sections within that encompassing title. And they begin with E's, such as exploration, exercises, and evaluation. And indeed, like Audra mentioned, these are modeled after the 5 E's of science learning. We incorporate 3 of those E's into our laboratory curriculum. On the landing page for each of those sections, you'll see the sections stated again: exploration, experimentation, and evaluation. These sections are gated, meaning the student has to complete each one in order before they're able to access the next section. Very important, at the beginning of every section, the student encounters a time allocation bar. So it's that gray highlighted section at the top of the student page. One of the biggest challenges that online laboratory students have is allocating the proper amount of time to be successful with the procedures and answering the questions that come afterwards. This is a very different environment for your online students compared to their on-campus peers. They're not showing up at a pre-described time and date once or twice a week to complete laboratory activities. The schedule that they make for their at-home labs is totally on them. And all we can do is to set them up to succeed. And in order to do that, we need to clearly and effectively communicate how much time, not only for the lesson as a whole, but for each individual section, the student should allocate to be successful. After reviewing the time allocation requirements, the student will encounter the detailed learning objectives for each section. we model our learning objectives after Bloom's taxonomy, which fits in nicely with constructivist learning theory and the 5 Ds of science learning. These learning objectives are very specific to the tasks students are expected to accomplish, and every one of them is evaluated with one or more questions. So we can track how well students accomplish the objectives for each lab. Now, in the exploration section, and according again to Bloom's taxonomy, these are lower levels of understanding. So you'll see verbs such as describe, define, and compare. Now, once a student reviews the learning objectives, they don't merely just jump right into the lab. They actually take a pre-test. So you'll see this bar in blue at the bottom of the student page labeled Test Your Knowledge. And this specifically is a formative assessment. It's designed to determine how much knowledge the student has coming in to this particular lab. So, you know, has this information been covered in the lecture? How well grounded is the student? The whole goal of this Test Your Knowledge section is for the student to be aware of any learning gaps that may exist. So if I have any success here, I'm going to click into a live student instance right now and show you how this works. So these questions are always drag and drop by design. Studies have shown that in an online environment, drag and drop questions are the most engaging. So we want the first activity that a student does to be as engaging as absolutely possible. So a student drags answers to the appropriate cells, and I'm paying no attention here, by the way, so hopefully I'll miss them. And then they click check answer. And they're provided, as you see, with immediate feedback. So this allows the student to identify any key concepts they don't yet understand. Now, there's typically 2 or more of these Test Your Knowledge questions, and they are always, again, drag and drop in functionality, but we saw the first one was matching. This particular one is categorization. So, but again, it's drag and drop. A student's identifying compounds as acids and bases, and they're checking their answer. And then that continues. Now, because student experiences are gated and they have to complete all questions, I'm going to jump now back into our demo course so we can speed through this a little quicker than having to answer every single thing. So, well, I thought I could, and it is. Here we go. So once a student completes that formative assessment, they are ready to begin the lab itself. Now, before a student starts any procedures, they have a refresher of all the key concepts addressed in the laboratory. And this is what makes up the bulk of the exploration section. And we design our exploration pages very purposefully, in that we have blocks of text, but never too much at one time, with all important terms occurring in bold. And then those text panels are always accompanied by graphic representations of those concepts. And they can be photographs, as we see here. They could be data type graphs. They could be diagrams or a series of formulas. Certainly when we're talking about chemistry and physics, students will encounter formulas almost always at some point within the exploration section. Now, at the bottom of each of these exploration content pages, a student will find a question time activity that they must complete before advancing to the next page. Now, these question times are in the format of multiple choice questions. And when students answer these multiple choice questions and click check answer, just like we saw with the drag and drop questions, they are provided with immediate feedback. Now, these questions are designed to specifically test the student's understanding of the content that is presented on that particular page. So, and again, there may be 1 or more of these questions. but these pages are gated. So if this were a live student view, they would have to answer these questions before they can page ahead. Now, because this is a demo, I can page ahead as a presenter. Here we see another example of a content page. Like I promised, there are formulas involved. The formulas break up the text, or here's a diagram that breaks up the text. Also scattered throughout the background, i.e. exploration sections of our labs, are did you know boxes. You can think of these as relevant information panels. So these show that, you know, anytime a student can relate to new content, they do learn it more effectively. So these relevant information panels are always designed to hopefully present something the student already understands in context to the new content being presented in the lab. Now, once a student gets through all of the exploration content, they should have the foundation of knowledge required to understand not only why they're about to conduct the laboratory procedures as they are, but more importantly, what the results will mean. So let's jump ahead then to the next section labeled experimentation. And as you might imagine, this is where the procedures are located for the hands-on activities. Again, we have a time allocation statement, very, very important. And almost always the time allocations for the experimentation section are going to be many folds longer or larger than the time allocations for the other two sections. Learning objectives are clearly stated again. These are more advanced levels of learning, more active terms such as classify and determine. You could easily see things like measure and compute here too. And that's followed by a detailed materials table. Now, for all of our hands-on labs, students are going to have a combination of materials they should have on hand, i.e. household items, and then materials located in their lab kit that we provide. Now, we provide science grade materials. So you'll see in this HOL supplied items, the student is going to have personal protective gear like gloves and goggles, and then the physical materials needed to conduct the procedures. In this particular instance, it's the pH strips, a test tube cleaning brush, well plate, and a variety of chemicals. Now, you're probably seeing these chemicals and realizing some of them are quite strong acids and bases, and red flags are going off, I'm sure. But I challenge you to look at the volumes that are being shipped to students. And the highest volume you'll see on this chart is 3 milliliters. And I'm about to show you a photo of how we package our chemical. And it's very ingenuitive. You know, when chemistry was the first discipline we launched in our company's history 20 plus years ago, you know, before the at least commonality of online education. And our founder, who was a PhD chemist, really had to rethink, you know, how do you teach chemistry remote? And he was fortuitous enough to partner with another fledgling company at that time that provided a solution for us to be able to ship chemicals not only safely, meaning so they wouldn't leak in transit and wouldn't pose a hazard to the shipping companies, but just as importantly, provide chemicals that were packaged in a way that students could use them one time for one experiment, not have to worry about spills, and work in volumes that were so small that even if a student did misplace a drop of the chemical, it was very unlikely to cause any problems for them or anyone or thing located in the environment where they were conducting the experiment. So let's take a look at that. So our experiments, or labs, I should say, typically consist of 1 to 3 exercises. And these exercises are designed like you're about to see here. Exercises often contain videos of common techniques. And for example, let me mute this one. This one starts out with opening a chemical pipette. And this indeed is how we package our chemicals. So you'll notice they're in dropper pipettes that are hermetically sealed. The student is expected to open those with a pair of scissors. They are stored upside down in a well plate so they don't drip while the student is conducting the procedures. And then again, the volumes within those sealed pipettes is never more than 3 milliliters. So very small scale, very safe. And we'll go ahead and pause that video. Now, we design our procedures in very clearly written steps. The biggest challenge that a remote science student has when conducting laboratory procedures is that they can't raise their hand when they have a question. So unlike your on-campus students, they can raise their hand and have their TA or yourself walk over and explain a procedure or actually physically show them how to do something that they're unclear about. Your remote students do not have that benefit. So it is imperative when we write the curriculum for those students, certainly the procedures, that we're aware of that and that we write them very, very straightforward, always beginning with the verb and very concise. So 1 sentence per step whenever possible, always accompanied by photographs of someone doing exactly what the student is being told to do in the procedures, so that the students are visually guided so that they can successfully set up their experiment. The last thing we want your students to do is to become frustrated. And because we know that once a learner is frustrated, they can't focus on the task at hand. And even if they do, they can't recall what they did afterwards or what it all meant. And that's not the outcome that we're looking for your online students. This one has a couple videos in it. For example, we always give students warnings, things they need to be aware of. And then we always provide data tables or some type of response panels for students to record their data and observations and results of their procedures. And students access these data tables that are called out in bold at the bottom right-hand corner of their computing device's screen. And when they click the data table, it pulls up and maximizes or the size of screen the student is using and allows them to easily input their results. As a student is inputting their results, the platform saves their work every 3rd second. So students don't have to worry that they forget to hit save or they have a power outage and lose their work or any of those types of things. The platform is very responsive and automatically updates and saves students' input. Speaking of the platform and speaking more specifically of why we designed these data panels the way we did, is that the HOL Cloud platform in our curriculum is device agnostic and responsive, meaning that students can use a traditional desktop computer, a laptop or notebook computer, or even a tablet to access the curriculum and to input their work while conducting procedures. So both the text and images and data tables and everything associated with the curriculum will auto-size in response to the student's computing screen. At the bottom of every procedure page is a series of open-ended questions that are designed for students to relate their experimental outcomes to the concepts addressed in the lab. These are short answer always, and we do provide a detailed instructor answer key in conjunction with this. This whole system is automated, and a little bit later on I'll show you instructor tools and show you how that works. But rest assured, we do want to appeal to the requirements of your course, and a lot of times you do require students to demonstrate a higher level of understanding than just simply answering true-false questions or recording some data. And we have incorporated those higher levels of questions into all of our curriculum. Now, many of our experiments, like I said, consist of more than one set of procedures. In this particular lab, there's 3. And here again are examples of other types of reactions that students are observing. And this one requires quite a bit of computations by the student, but again, we provide them with, in the exploration section, the requisite formulas they need for that, and also with examples of the chemical reactions here that they will be conducting. Again, they have a responsive data table that slides up, and students are provided with photo panels. And you may be wondering, well, what's the purpose of a photo panel? It is best practices for online science students to submit photographic evidence of the completion of their procedures. You know, we get questions, and understandably so, from a lot of potential online instructors that go something like this. How do I know my students actually conducted the procedures? Well, we've thought of that, and we've incorporated into our labs, and that most every lab requires a student to take a photograph of the results of, in this case, the reactions that they set up, because these have colors, indicators in them and whatnot, and upload a photo of those results along with a name, time, and date stamp on the photo, so that you, the instructor, do have evidence that the student successfully performed the procedures. So at the conclusion of the experimentation section, the student has now completed all of their procedures, submitted data, uploaded photographs, answered those more thought-provoking, open-ended questions. So there's only one thing left for them to do now within our lab manual curriculum, and that is to take a final exam for every lab. And that exam occurs in the evaluation section of our lab manual. The evaluation section begins, not surprisingly, with yet another time allocation statement, immediately followed by a review of all the learning objectives from the previous 2 sections. Then the student is ready to begin the evaluation. They're given a warning so that they understand that once they begin this exam, they cannot page back. Meaning this is designed to test their understanding after having completed the lab, and the point is not to look up answers. And in fact, they're going to be locked out of the lab. They can't look up the answers. A student starts the evaluation. There is a timer on this. While the student does not have a time limit, this is time so you, the instructor, can see how much time the student spent answering the questions. And then these are always multiple choice questions. The student answers them. They continue to advance. At the end of this, and I'll quickly go through these, you'll see that there's usually about a dozen or so of these questions. They span the whole breadth of the lab, from the exploration section to the step-by-step procedures to the results, and then the big picture at the end. When a student completes this, it automatically submits their work. And this one is freezing because it's my demo, but then what happens is the student is provided with a final report, lets them know which questions they got right, which ones they missed, and where in the lab each of those answers occurred. So that concludes an overview of a student's experience using the lab manual, an idea of some of the materials they use to conduct the procedures and how those procedures are written, and then how a student is tested at the conclusion of every lab. So as promised, we're halfway through. Rest assured, the rest of my presentation does not take as long as this part did, because we've seen a lot of these things before when we're in instructor view. So as promised, I'm going to take a 2-minute break, and while I'm doing that, I encourage my team to forward, unmute one person, please, and forward any questions that you've seen that you think would be better directed to me that have already come over, and then we'll resume in just a couple of minutes.
I'll have those questions over to you, Dr. Duane.
All right, thank you for waving, everyone. Now what I want us to do is to take a look at the tools that we've designed into our curriculum hosting platform to facilitate your duties and obligations as an online instructor. So we saw that student landing page at the beginning of the presentation a number of minutes ago, which was simply a list of the lessons. What you're seeing on the screen now is the instructor landing page for an online lab, and it's very different. So what are we seeing here? We're seeing a dashboard, and on this dashboard, we're seeing at the bottom the names of all the students that are enrolled in this particular class. Now, you may recognize some of these students. I think we've got a really nice a conglomeration of individuals from Snoop Dogg and Martha, who are back together again, by the way, taking chemistry, all the way to our everyone's favorite senior citizen, Betty White. So, and then a few others sprinkled in. But anyway, not to make too much light of this, but just to show you that this is where your students' information lives, is on your home course page. And then there are a series of circles by each student's name, and it lets you, the instructor, see their progress in the lab. We do provide you with a legend, so that is color keyed, so you know what the different colors mean beside each of the students' names. So, and you can always hover over any of the bubbles and it'll give you the title of the lab that the students have completed or that are currently working on. So by the way, when we're using the drag and drop questions earlier and getting the immediate feedback, we were using Betty White's account. So she's got a gray right there by acid-base chemistry because we started that officially for Betty. You know, she needs all the help she can get these days. But anyway, so let's move on. So what else can I as an instructor do other than just get a snapshot of where my students are? Well, most importantly, as an instructor, I can add or delete students from my course using this registry here. And then most importantly of all, I have access and control over all the labs that my students are completing. So you'll notice that same list of labs on this instructor lesson page that we saw on the student landing page. We see the two prerequisites, they're in gray on the instructor view, and then the blue coded lessons are all of the labs themselves. Now, as an instructor, I have several options here. I can choose to require sequential completion of lessons, meaning my students have to conduct the lessons in a particular order. And then if I choose that, I can actually go in as an instructor and change the order of the labs so it best meets the flow of my lecture course. Or if I want to make this open to the students and allow them to jump around however they want, I can uncheck this. And then lastly, if for some reason I only want students to begin a lesson on a particular date, I can uncheck the lessons. As soon as I uncheck them, they are not visible to my students. So meaning that students only see one title, like you see here. And as an instructor, indeed, I can toggle back and forth between instructor mode and student mode. So I always know what my students are looking at. What else can I do on this landing page? I can also leave notes to my students. And then when students log in, if we were back in Betty's real student account, she would see my notes right up here above the prerequisites. So what else can we do? Well, very importantly, we can preview materials and we can provide students with additional documents. But before I cover that, I want to actually show you some tools within a lesson that you have. And let's look at a different lesson just for variety's sake. You'll notice in instructor view, this looks almost identical to what it looked like in student view, but there are going to be some key differences. And those key differences are that on these content pages, as an instructor, if I scroll down them, I see a series of pulsing blue bars. And these blue bars allow me to add additional content to a curricular page. And that additional content can be in the form of text, images, or even videos. So if you have some information that you've always taught your on-campus students regarding, in this case, ionic compounds, you can upload that content directly and seamlessly within the existing lab content that we provide for your online students. And again, that can be text, images, or videos. When you enter that, let's enter some text, and you hit save, it appears in this grayish beige tint. And indeed, it looks that way for your students too. So then when they encounter it within their online lab manual, their attention is automatically focused on the content that you have uploaded onto the platform. Now, you're not only restricted to just doing that in the evaluation, indeed, you can add supplemental content, supplemental instructions, videos, images, and the like also within the procedure pages. You know, I have a lot of instructors that like to film themselves or some on-campus students doing particular procedures that match up with the procedures that students are conducting in the online course, and upload those videos so students can not only conduct procedures using the materials in their kit, but at the same time view exactly how these procedures occur on campus. So it really gives the students a better understanding of how this works in multiple environments. Now, instructors, as I promised, they had these integrated answers to those open-ended questions that we saw in the student view. And also, same goes for the data tables. So that's some quick tools that are built into the platform for instructors regarding the curriculum. But we didn't stop with the instructor tools just yet. We also wanted to give you tools for actually assessing your students. And that's what's called the Gradebook tool on HOL Cloud. And you probably have a similar Gradebook tool or something called that within your learning management system environment. So I just want to give you an idea of how it functions within our lab manual. And within the lab manual, when you click on Gradebook, again, all of your students populate, you see their progress, but more importantly, you have control over the points and weight of the questions in all of the labs that your students are going to be answering questions in. And to do that, you simply click on a title, it expands, and it gives you a list of every single question that is built into that lab. Everything from those drag and drop formative assessments to the multiple choice questions at the bottom of each exploration page, to the data tables, the open-ended questions, and then that final exam with each of the multiple choice interactive questions that live there. When we deliver the content to you in a new course, the default is 1 point per question. Now, as an educator, you're probably thinking, well, you might not want to grade test your knowledge questions. They're formative assessments, and they're really designed to make a student aware of what they know. I wouldn't want to grade them anyway, so you can mark those as 0, no problem at all. Student still has to answer them. The student has no idea how much weight you've put on each of the questions, but from a grading standpoint, you have control over that. Just the opposite, if you want to give a lot of weight to the open-ended discussion questions at the end of the procedure page, you can easily change all of those. Once you make these changes and you hit save down here, this is stored on the platform. So even though your students are going to change from semester to semester, the way you've set up the grading rubric for the class is locked into the system until you go in and change it again. So you no worry about ever losing your work and how you set things up. What does it look like to grade a student? Let's take a quick look. This lesson has been submitted and locked. Boo. Okay, well, I needed to go back and unlock one of these other lessons, but let's do that quickly. Now we can grade a student. Maybe, maybe not. All right, well, I told you, some days I have system challenges. But to grade a student, if one of these other green bubbles, other than these 2 prerequisite lessons, was in progress, we could click on the bubble, we would see every student response, and then we would see the answer key beside of it. An instructor, again, are the open-ended questions and the data tables if we choose to grade those. Everything else in the evaluation section and in the exploration section are auto-graded by the platform. All you do is once you set the point values and you never have to touch those again. The system grades them for you. What else have we made available to you as an instructor? Well, we've given you the option to add unique lessons to your online laboratory manual. So again, we write curriculum, we build lessons, we supply physical materials, but we know that you may have some unique topics in your course that either can't be supported by physical materials, or they're extra credit type projects, or you want to give an overall semester cumulative exam. Whatever you would like to do, we make authoring tools available to you. We call it custom lesson authoring. We allow you to design either complete lessons or parts of lessons that your students can then complete within the lab manual platform. So again, they could be just the exploration section, they could be just the evaluation section, or they could be procedures that didn't involve, the physical materials in our kit. So however you would like to author content, you do have the ability to do that on our platform. And then lastly, and very importantly, we give you access to all of the internal settings for your online laboratory lab manual, meaning we give you a unique link that you can share with your students so they can self-enroll on the platform. And we give you and your IT team access to all the learning technology integration credentials. So you can fully integrate our lab manual within your existing learning management system, including the gradebook function and the weights you've given to all the questions. So that the grades live in only one environment then, and that's your LMS. Same thing for the lessons. So it truly is a single sign-on for your students. Once they're in your learning management system, they're in our lab manual. We have both instructional manuals and real people to help you with this, should you choose to integrate our content into your LMS. The last thing I want to mention is, I know we probably had a question come up already, and I'm sure my panelists have already answered it, but inevitably we get questions about ADA compliance, and I do want to share that with you, that all of our content that we host online, so all of the textual content, all of the images and the videos, all of that is ADA compliant, meaning students with screen readers can read the content. The images have supplemental text explanations to them, and all the videos are closed captioned. If some of our topics have animations built into them, and to control those animations, also those are keyboard controlled in addition to mouse controlled, so they are ADA compliant. So I wanted to finish early on purpose, because based on the other of these webinars that we've done this week, we have lots of questions, and I want to make sure that this last 15 minutes is allocated just to your questions. And again, I'm going to encourage my panelists, if there are any science-specific questions, please unmute yourself and ask away for the benefit of everyone in the audience. I typically don't type in responses to questions like the panelists do. So again, if there's any relevant science questions, please feel free to ask.
Hi, Duane, it's Amanda. I wanted to reach out to you about a couple of the questions that I saw. We have a lot of instructors online right now asking about our organic chemistry lessons. Well, what do we currently have to offer right now, and what are we working on?
I mean, what we currently have is on our website, so we always defer lessons like that to, or questions like that to our website. You'll see a complete list per discipline. We are always working on content, including organic chemistry. I'm not the project manager for that, but you know, rumor has it that stuff was more content for organic chemistry should be coming online this summer, i.e. August. But again, all of our current topics that are ready for current review and adoption are listed on our website under our chemistry tab. But certainly expanding organic chemistry topics is currently in progress as we speak. You may understand, certainly if you teach organic right now, organic is a little more challenging in a remote environment due to the nature of the compounds and the types of reactions that go along with that. So not only from the student end of, you know, are we dealing with noxious fumes and potentially hazardous materials along those lines, but just as importantly from the shipping end. If you've had experience with ordering chemicals for your school or spending time in your chemistry stockroom and how those compounds come in, you know immediately that that's not how students use them. So one challenge we and anyone who needs to ship organic-based compounds, science grade to students would run into is many of those we can't ship traditionally, and then therefore we can't kit them. But having said that, we have found alternative solutions, and again, we have a selection of organic chemistry labs currently in our library, and we'll have more in the coming months.
Great, thank you. Another big question that was brought up was, are students instructed to neutralize all of the chemicals at the end of a lesson by mixing them together and then disposing of them down a drain?
Let's talk about chemical disposal. It always comes up. I cannot legally tell your students how to dispose of their chemicals because the laws for disposing of chemicals around the country vary not by state, but by county. And as soon as I would give you, your student, an exact answer on what to do with their compounds, it would violate one county's provisions out of the hundreds in our nation. So in the lab safety in prerequisite lesson, we clearly explain to students, and this is not unique just to chemistry, is that it is imperative that they check with the local rules and regulations for disposing of any materials, not just chemicals, but things like dissection specimens, if we're talking about some of our other disciplines. I mean, we can give you what we would think are best practices to dispose of something, or, you know, what works for our physical location. But again, I cannot tell your students something that's going to violate their local law. So yeah, is best practices to neutralize something and then wash it down the drain? Yeah, but some states, counties, you can't put anything like that down the drain. So in those, you may need to put it in paper towels and dispose of it as solid waste. So that's a very, very tricky question with a lot of legalities involved. And at the end of the day, primarily, you know, students are dealing with residual compounds less than a milliliter of any given compound. So it's tiny. If I had these to deal with, I would simply squirt them in a paper towel. That's me. Nothing's going to be flammable. Nothing's going to digest the cellulose in there that students are using. But no, I can't tell your students to put something down the drain when I know for a fact in California, especially, that is not good. So, but thank you for that question. And I would encourage you as a potential or current online instructor, if your students are using chemicals from any provider, that you need to communicate something similar. Because your students are online, they can live anywhere. And so it's not, again, like your campus environment where you have very set protocols based on your institution, and your campus is only located in one location, so it falls under one jurisdiction. Online, it's very, very different. So, but thank you for that question. It's a wonderful one, and it's a challenging question. I mean, what we've done as a provider is to make sure the amount of chemicals we provide students is very, very small, we've seen.
Great, thank you. One of the other questions that was brought up was safety and liability. Can you go into just a little more detail on how we handle liability versus, you know, the school assuming liability?
We assume all liability if your students conduct the procedures using the materials that we provide and using the step-by-step protocols that we instruct in our online lab manual. As long as they follow our instructions and our materials, if there are any accidents that incur any injury, we are 100% liable, not your institution. That's as succinctly as I can put it.
Okay, and just a couple more questions. What can you speak about with ADA compliance, especially screen readers for students that are visually impaired, closed captioning, so on and so forth?
Yeah, I covered that at the end. Yeah, we are ADA compliant. So any of the content that's in our online lab manual is ADA compliant, meaning, again, that the text is screen reader compatible. All the images have descriptive downloads that go along with them, and all of the videos are closed captioning, and anything that a student has to do to manipulate anything on the platform, whether it's just submitting work, answering questions, or if it's an animation where they need to adjust that, all of that is keyboard and mouse both controlled, and that's totally interchangeable, which is another part of being ADA compliant.
Wonderful. And then one last question that I saw come up a few times was, can assessment questions be easily Googled? Like, what have we put in place to protect our content?
So let's talk about online education in general. So one thing that neither we as a provider nor you as an educator nor anyone out there could do is to prevent your students from looking something up. I can prevent your students from looking stuff up in my curriculum once they've begun their final exam, but I cannot control what's on the internet, nor can you. I cannot control a student using Google or not, nor can you. I cannot control third parties that charge students fees to sell them answers to questions. So again, none of us have control over that. We all want control over it, but none of us have control over that. And this really transcends online education. I mean, this goes to face-to-face education too. So no, I don't know how you could keep someone from Googling something that's not compatible with the 21st century. You know? Yeah.
They were asking just if they're easily Googled. So like if someone put in hands-on labs, acid-base chemistry, answer key, like could they easily find that?
They could, and it could be our answer key from 10 years ago for this lab that before we even had the platform. Everything's out there. So again, if a student at any point in time has turned something in, yeah, we can go in and refresh our questions all the time, but your students can still find something. Doesn't mean it's current, but I guarantee you your own exams that your students have taken over the years are on campus or online in some repository somewhere that charges money for people to access. We've looked into this from a legal matter. It is extremely prevalent, and unfortunately, there's no way to stop it. But all we can do is to refresh our content from time to time, as that's all you can do as a lecturer and on-campus instructor.
One last question is just what kind of goggles and gloves are the students given?
For chemistry, they're using splash-type, vented, properly chemistry-approved goggles. We supply students with nitrile gloves.
Okay, great. Thank you. I'm not seeing any last-minute questions pop up. So Dr. D, thank you very much for your time. I appreciate everything that you've done. We appreciate all of you attending with us. And if you have further questions, please do not hesitate to reach out to us. We will get you in contact with your dedicated sales rep to get you all squared away. If it's a question that even they can't answer, like I said, we have Dr. D here who can answer questions and all the other scientists on our team. Thank you so much for meeting with us today. And Dr. Duane, thank you very much for your time.
All right. Take care, everyone. We look forward to serving your needs in the future, and we hope you have a wonderful weekend.
Stay safe, stay healthy.